In this video I will describe how to export data from your PCB CAD system and convert it into a format that you can then import into the pick and place software. It's not nearly as difficult as it may first appear, and although the manufacturers of the pick and place machines specify that only certain files can be used from certain CAD systems, that's not the case. I suspect they've done that just to simplify the instructions they're providing. But it is fairly straightforward to create a CSV file from pretty much any CAD system that you can then import into the pick and place machine. So the first thing you need to decide is if you intend to palletize your boards. So if you're not familiar with palletization, it's just really duplicating the board multiple times on a single larger board. It's especially useful for very small boards because it makes them easier to handle. It also makes them cheaper to manufacture. So this board I've created here, it's not really a board, it's not, there are no tracks or anything, this is just components. The pick and place machine doesn't care about tracks, it only cares about component positions and orientation. But it's a fairly small board, it's about 30mm by 50, so it's a good candidate for palletization. So palletization essentially means you take the board and then you copy it multiple times. So in this case we'll copy it in a grid array of 4 in the X direction and 5 in the Y direction. And then what we end up with is a larger board that you can then export to your Gerber files and send to the board manufacturer. I don't actually recommend doing it this way simply because you will then have to deal with every single component when you come to creating the pick and place work file. It's far easier to keep a single smaller board and then have the manufacturer palletize it. You'll end up with the same resulting PCB that's delivered to you, be identical. The only difference is that you will then palletize it on the pick and place machine rather than prior to the board being manufactured. So you'll only need to deal with the components that are on the single version of the board, and then what you do is you just essentially step and place the job across the area of the board. And we'll come to that when we look at the pick and place machine itself. So in this demonstration I'll just stick to the smaller board. These instructions apply equally well to larger boards and boards with far more components on them. The steps are the same. I'm just keeping it simple here so it doesn't get too tedious and too boring. So before we export the data, let's have a look at what the pick and place machine requires in the CSV file before you can import it. So this is the pick and place software, and if we open a job file, then you'll see the various fields that the pick and place machine requires to run. So if we look at the fields, we have a component number, a head number. The head is the picker head. There are 2 heads on this machine, and this column determines which of the heads will be used to pick this particular component. The feeder, that's the reel that the actual component is in. The X and Y locations for the center of the component. The angle that the component should be placed onto the board. This is something we'll come back to when we start looking at the machine, because you do need to make sure that the coordinates do tie up with the machine, and also that the angle that you rotate by is suitable for the machine relative to your CAD system. They do vary, and you do need to make sure it's correct, otherwise you'll be placing components in the wrong place or they'll be facing the wrong way. Height of the component, this is just the thickness of the component, and you can get that from its specification. The speed, how quickly the machine will move to place this component. So larger components you might need to slow the machine down to make sure you get accurate alignment. Designator, this is really just a description of the part to uniquely identify them, and same with ID, that's just the ID of the particular component. So bear in mind these are the fields that it needs for identifying the particular component. There's one other type of information that the machine needs in order to successfully build a board, and that is it needs to know where a particular component is on the machine. So if we look at the feeders screen, in this case this board needs 3 components, so there are 3 feeders, one for each component, and the information in here is actually derived from the file that you import. Now you can do all this manually, but it's very tedious, so it's just easier to create the CSV file, and if you've done it correctly then you'll get the correct number of feeders with the correct designations for the components. Also, with the advanced amount, that's something that you will probably need to enter manually. We'll come back to that in a few minutes when we look at what's in the actual work file. But this is just how far apart the components are spaced on the tape. And then X offset and Y offsets are just tweaking values to make sure that the machine can pick the components accurately. And again, we have a speed setting for the particular reels, feeders, to make sure that you have full control over the way that the machine operates. There is a batch process where you can effectively tell the machine about the palletization that you've created, but we'll come back to that on another video when we look at palletizing the boards. But just bear in mind that if you palletize the board for manufacture, then either you need to do that within the software and tell the machine that this is a palletized board, or you need to separate all the boards and then just run them one at a time, which is obviously far less efficient. Okay, so now we know what the machine is looking for. Let's have a look in the work file to see how we can go about creating the correct export. Okay, so this is what's in a work file. It's quite easy to understand because it is all in fairly simple text, and it's broken up into blocks. In each block is for a particular purpose within the machine. So the top part is just information for this particular file, and you can pretty much ignore that. The next block down is the section of the file for the feeders. So this defines how many feeders there are, what they are, what component they hold. And you can look at the table header, which is across the top here, and get a good idea as to what each column within the table holds, or what information it holds. This is derived from the data that's in the CSV file. Now, as long as you get the component information right within the CSV file, then this will all be correct and you won't need to do much more with it. The only things you're likely to need to change are the size columns. If you look at second and third feeders, they're set to 0, but in the first feeder they have values that don't make sense. When I say they don't make sense, this information is used by the pick and place machine by the up-facing camera. So when the machine picks a component, it goes to the up-facing camera if you have that enabled for the particular job, and it looks at the component. Not only does it make sure that there is a component there, but it checks its orientation, and it also optionally checks the size of the component to make sure you've got the right feeder in the right slot. Now, this information is taken from the CSV file, so in EagleCAD systems, as well as having the X and Y location for the particular components, it also has additional pad information for the components. And a lot of other CAD systems can do that, but because some don't, I've set this to ignore it. And a value of 0 means ignore the size of the component, just check its orientation. The information is taken by looking at the X and Y value of the components, and then the software, when you import the file, uses the pad information for the particular component to work out its size. And here it's saying that this component is 400mm by 600mm, which is obviously nonsense. So you can manually change it to whatever you want. If you know the size of the component, then you can enter it, and that will give you a double check on the component to make sure it's the right size. You shouldn't need it. As long as you've got the right components in the right places, then you don't need to take any notice of that. The rest of the information should be correct. But as I said, you can look at the header and figure out what each column actually means and then edit it if you need to. Generally, I don't edit these files directly. I edit the CSV file, and we'll come to that in a few minutes. The next section in the file is a table containing information for all the components. So again, you can look at the header, and that will give you a good idea as to what information is required in the file. Now, these are requirements for the job itself. It's not a direct one-to-one relationship between what's in the CSV file, because obviously it adds additional data. But what you need to do is make sure that all these columns are present and in the right order in your CSV file. If your CAD system can't output a file with all this information, then you can edit the missing parts manually, and I'll show you how to do that in a few minutes. But essentially what you're looking for is a minimum of the X and Y centers for the components, and then the angle of each component. Here, where it says explain, this is just a textual comment of what each component is. In this case, we've got 3K3 resistor. Now, this is not important in terms of what it's actually saying, but it is important that it is unique for each particular type of component, simply because this information is used to determine what particular feeders are going to be created and where these components are on the machine. The rest of the information you can manually edit within the CSV file. You shouldn't really need to come in here and edit this particular file. And then finally, at the bottom of the file, we've got some calibration information for the machine. So this is information such as where the origin of the PCB is, how big the PCB is, and where the calibration points are. So we'll have a more in-depth look at that when we look at calibrating the PCB on the machine. So this information will be things such as where the origin of the PCB is, and any identifying marks on the PCB that the pick and place machine needs to know exactly where the PCB is, how big it is, and where the components are within the PCB. So the way the pick and place machine works is you essentially give it 2 or more calibration points, and then it will interpolate all the intermediate positions to determine where each component lays and needs to be placed. We'll look at this in more detail when we get to the machine, but just bear in mind that it's a good idea to include some calibration points on your PCB design, and again we'll look at that later. So this is the information we need to get from the CSV file. So if we now look at the CAD system again, and then we can export the minimal data that we need to create the CSV file, and then we'll look at editing that file to create a file we can import into the pick and place machine. So back at the CAD system, we have the board, and now we want to export the data into a CSV file. The way you do this will vary depending on the CAD system you have, but I think pretty much every PCB CAD system will allow you to export a CSV file that contains at least the component X and Y positions along with their descriptions and the orientation of the component. So in my CAD system there are various reports I can create. I've created one here called Pick and Place. I'll give you a quick look at what's in there. Now, although you could export just the coordinates and the orientation and the name of the components and then create the extra columns in Excel, I've found it easier just to create some dummy fields that I will manually edit within the CSV file externally. That just makes sure I don't forget any and also keeps them in the right order. The only ones that we're really particularly interested in is we have an ID number column that is actually blank. I've got it set just to give out a null value. You could do that with the rest of the fields that aren't important, but I just want to show you how to edit the file. Designator, which is the name, and comment, which is also the name, and these are used to allow the software to extract information it needs on the feeders that are required. The X coordinate, the Y coordinate, and in some CAD systems you'll have a ref X, ref Y, pad X, pad Y, and these are just information about the pads. As I said, the software can work out the size of the component, but we don't use this, so they will be set to 0. But I've included them here just to show you how to deal with them if your system just does create them. Layer, so that is, I've just got it set to say top, so these are all top layer components. Bear in mind you can do top and bottom on a pick and place machine. The angle, that's the orientation or rotation of the components, and comment is just a description of the component. Make sure you've got your separator set to a comma, and then you can run the job to create the CSV file, and this is what we end up with. You can see the first column, as I said, is the ID number and it's blank, and then we have various other bits of information that we will use within the CSV file, and then ultimately we'll import it into the pick and place software. So I'll now open this file in Excel and we'll see how to edit it. So the file is now open in Excel, and as you can see we have a column for each of the values that we output. The particular columns that you end up with and their names is entirely up to you, but as long as you have a minimal of X coordinate, Y coordinate and angle, also preferably there as well, then you can add the additional columns. But as I said, it's easier if you put in the dummy columns to make sure that you have all the correct columns and in the right order. So the first column is the ID number of the component. We've got a header here that is obviously not indicative of a particular component, but don't remove it. You need that there, otherwise the import within the software will ignore the first component. So in other words, the import function within the software expects there to be a header that it's going to ignore. If you remove the header, then it will ignore the first component instead. So just make sure you've got a header there. It doesn't matter what it says as long as it's there. So we will now put in the information that we want. So if we start with a value of 0, and then we'll number them up through 30. So bear in mind, when this is imported, the actual component values will be numbered from 1 to 30. If you want them numbering from 0, then obviously change the number, and you can set this to whatever you want. Designator, as I said, it's just a description, and you need to make sure that each of your components that you want to be in a single feeder have exactly the same information within this column, and that's how the software determines which particular feeder to use for a particular component. Footprint, you can ignore that. Again, it's just really for your information, but the column does need to be there. X coordinates, Y coordinates. Now naturally those columns are required. You can't get away without those, and this is really why you want to export the CSV file, because it would be very tedious and error prone to try and do this by hand. We'll come back to the X and Y coordinates when we look at the actual machine itself, because you do need to make sure that these are the right way round and also in the right directions. In my particular CAD system, I had to reverse these, otherwise the X direction was wrong, and it was trying to put the components out of the window, which isn't going to work. Ref X, Y, etc. We don't need these. This is all information that is output for the machine to work out component sizes, but because we're not going to bother with component size, at least I'm not, you can set all these to 0 and it will work just fine. Layer, as I said, I've got all these set to top, but that again can be anything that you want, but the column does need to be there. Angle, that's the orientation of the component on the board, and is again another of the columns that you do need to export from your CAD system. We'll come back to this again when we start looking at the machine itself, because as with the coordinates, you do need to make sure that these are correct relative to your CAD system. And then comment, again, this can be anything that you like, but it is a required column. If you don't have it, then the machine isn't going to work properly. So once you've got the edits made, save the file, and then we can go to the pick and place software and see if we can import the file we've just created. So back at the pick and place software, we now want to import the CSV file that we've just created. So go to Files, Convert File, and then select the file that you want to convert. In this case, it's the one that we've just exported and edited. So open it. As long as it opens here, you can be fairly sure that you've got all the columns correct and the basic information in the columns is also correct. If any of that's not right, then this will just stay blank. The software is not particularly helpful sometimes, and some of the error codes you get are also not very helpful. But in the case of importing CSV files, if the file format is wrong, then you just won't get anything here at all, and it won't tell you why. So once you've got it imported, you can see that the information within the file is correct. You can see we've got the X and Y coordinates, and so we'll convert it into a job file. We've done that, and again, as long as it's being processed correctly, we can now see it has correctly identified that we need 3 feeders for this particular work file. So we can save the work file, give it whatever name you want, and we now have a work file that we can use to drive the machine. So if we go to run, this is the file that we've just created. We load it, we can see that we do in fact have all the components that we were expecting, 30 of them, and that none of them are missing. So this is the first component as we expected. If you want to check them, you can go back to the job file. You can load the job file, and then you can manually check each particular component on the board. You can even look at the position it should be in. So if you've got this far and the components are correctly showing, then it's fairly certain that you've got a file that you can at least use as the basis for running the job on the pick and place machine. There may be some things that need modifying or editing further, but we'll look at that when we get the file onto the pick and place machine, and we'll go through how to configure and align the PCB and the machine, and then how to run the actual job and how to check that the components are in the right place, and then what to do about it if they're not. So that will be in the next video. Any questions, or if you want clarification on what I've gone over in this video, then please drop me a comment.